day everyone, my name is Shazlina Software Banking Wakari with my crew number DE240084, and today I will be starting with our presentation by taking through for the introduction, background and objective of our industrial visit. As a team of student consultant engineer, our visit to MV Industry Stadium Bahar in Batu Pahat Johor serve as a vital bridge between our classroom theory and real-world engineering practice. While MV industry is fundamentally known as a textile and fabric manufacturer, the entire facility relies on heavily automated production machinery because their operation utilize a complex high-demand network of electrical machines. It provides the ideal engineering environment for us to achieve our four core technical objectives. First, to identify four distinct types of electrical machine running the plant, such as the motor, transformer, or generator. Second, to analyze the performance ratings and industrial application of each system. Third, to diagnose current operational bottlenecks or power quality issues affecting the machinery. And finally, to recommend practical engineering efficient engineering solutions to optimize their overall performance. Moving on to the background of the company itself, Anfi Industries in Berhad was established on 19 June 1993, bringing over 30 years of specialized manufacturing experience to the industry. Their main headquarters and production facility are located right here in Batu Pahat, where they run a large-scale operation powered by a workforce of approximately 330 workers. What makes this company particularly important to us is the strong academic industry synergy shared with our university. As shown in their official documentation, there is a formal letter of intent between UTHM and Afi Industry establishing a strategic partnership for research collaboration and acting as a joint research hub. A prime real-world example of this collaboration is an active senior pioneer year project FYP being conducted right now, which focuses directly on analyzing and optimizing their automated RO wastewater treatment process. This project highlights how our students are directly solving plant efficiency and environmental compliance issues on site. To give a quick summary of their profile before my team dive into the specific flow operations, their core business center around high quality narrow fabric, garment accessories, and elastic webbing. They maintain strict global quality compliance certification audited by Intertek and Bureau Veritas, making them a highly sophisticated facility for an engineering audit.
Assalamualaikum and hi. My name is Amirul Hakimi bin Anwar, AE240006. Today I will explain about electrical machine application. As you can see, there are 6 pictures in this slide, which is below them is the name of the machine. So the machine is above the name of the machine. So we start with the first picture. So the first picture, we have the precise rewinding machine. This machine primarily function is to transfer yarn from an original bobbin to a new cone. The term precise is critically here. It means the machine exercises microcontrol over thread tension and winding angle to prevent the fiber from snapping or tagging during transfer. So the second picture is the warp knitting machine. In this picture, it translates to the Chinese word. So it typically named as warp knitting machine. Okay, unlike traditional crossing weaving, this massive machine produces highly durable fabric like mesh or sportwear. By knitting thousands of yarn longitudinally and at extremely high speed, it requires immense stable mechanical power to drive thousands of individual needles simultaneously. Right, we move to the picture 3, which is the next machine, third machine. So the third machine is we have a weaving auxiliary machine, such as the warping machine. These do not with fabric directly. Instead, they are preparing the raw material, perfectly aligning and winding thousands of threads onto a massive central cylinder. This ensures the main loom runs smoothly without interrupting. Okay, so we move to the next slide. Um, we look at the right hand side. So the right hand side is the fork machine, which is I can say the name of the machine is winding machine. This act as the final package test, utilize dozens of individual station to pull processed yarn and wind it tightly onto commercial bobbies for storage and sale. Okay, that's all our four machine. So we move to the in the middle one, which is the motor classification lah. So first we have the three-phase squirrel cage motor. I mean three-phase induction motor. Okay, so this term focuses on the electromagnetic principle. Electric power is not fed to the rotor directly. Instead, the stator creates a rotational magnetic field that induces the rotor to spin. So we move to the next image, which is the left hand side. The left hand side is the name of the motor is three-phase squirrel cage. This term focuses purely on the physical design of the rotor. Instead of wire winding, it uses a solid metal bar that took like a hamster cage. Because it is brushless and spark free, it requires zero maintenance, making it the ultimate safety choice for a textile factory filled with highly combustible fabric dust. Okay, so we move to the next slide. The first image at the left hand side. Um, it is a three-phase AC induction motor. So this motor is functionally identical to the previous term, but it's explicitly highlight the power source. It's run directly on the factory heavy-duty alternating current grid, typically 380 or 515 volt. Distinguish it clearly from DC system. Okay, so the last image of our machine application is the three-phase AC, three-phase induction motor. This term focus on the electromagnetic principle. Electrical power is not fed to the rotor directly. Instead, the stator creates a rotational magnetic field that induces the rotor to spin. So, to conclude, the success of unfit industry continuously 24/7 production line rely heavily on matching the right motor and characteristic. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Iman bin Nur Azam, DE 240079, and I will be presenting on the problem that occur during our site industry visit. During the site visit, several issues related to electrical machine were observed. For the first one, operating multiple machines simultaneously may increase the risk of system overloading. Next, the production area experienced high noise level due to continuous operation of automated machinery. Then, heat generated by high temperature equipment can affect the surrounding environment and nearby equipment. Finally, continuous machine operation can increase maintenance requirement and the risk of unexpected downtime. Now, to address the issue, load management can be implemented to reduce peak demand. Second, noise levels can be minimized through acoustic barriers and vibration control measures. Additional ventilation can improve heat dissipation around high temperature equipment. Lastly, a preventive maintenance program can help improve equipment reliability and reduce downtime.
Discussion, there are three types that I should have talked about. We should talk about the small motor vulnerabilities, because also it was the small induction motor under 2 kilowatt may be economical, but the simulation breakdown of all motor such motor in facility could be bring an entire automatic tactile assembly line to the standstill. Second is that the optimization of energy efficiency. So some of the old motors being used have relatively low efficiency, IE3 or IE4. High efficiency motor will be greatly reduce the maximum demand charges for electricity per month. Lastly is the health and safety, because by reducing the risk of motor overheating, the fire danger resulting from dry cotton lean buildup on heated electrical component is reduced. Conclusion. In summary, the industrial site inspection has been quite successful in identifying 4 different types of electrical machine application used in driving various processes, including but not limited to the weaving processes, winding, and oscillators at the textile industry environment. It has established that extreme lean build-up, thermal shock through the start and stop cycles, voltage unbalances, and constant radial stress through belt-driven systems are the major contributors to deterioration of the motor insulation and bearings to the factory. Through the adoption of non-reactive maintenance practice and engineering measures such as TEFC housings, VFD speed controllers, and vibration sensing system, among others, the plant will improve in machine reliability and increase its energy efficiency significantly.